day viewers, welcome to my channel. If today is your first time, please consider to subscribe, share and like. So in today's video, we are going to look at how to determine the gradient of a particular function. So if you are given a particular function, be it quadratic function, okay, or linear function, then for you to determine the gradient of that particular function, you always have to find the gradient function, which is the first differential of a particular function, okay? And in case maybe when solving this you don't understand how to differentiate, please go back to differentiation. We've done lots and lots of problems already. Check the YouTube channel, okay? So now we are looking at the applications. How do you apply this differentiation topic, okay, to real problems, okay? So we have this question which is, if f of x equals to this, find the gradient of f of x at x equals to half. So at a particular point, you are asked to determine the gradient, okay? So for us to do that, always we have to find the first differential, which is f prime of x, since we are using x here. So you have to determine this, which is again the same as dy dx, because this one represents, if you represent f of x to be y, then this is x, then this becomes dy dx. So we have to differentiate this one, and we've dealt with how to differentiate functions that are in a bracket that do have powers. You can just use chain rule, okay? So for you to differentiate this one, you multiply this, so this becomes 2 into x squared plus 3, okay? Then 2 minus 1, which is just 1, multiply. Now you differentiate what is inside the bracket. So if you differentiate x squared plus 3, that gives you 2x, okay? So f prime of x equals to, if you multiply this, gives you 4x into x squared plus 3. So now you just have to clear the brackets. This becomes 4x cubed plus 12x. Okay, so this is the gradient function. So for you to determine now the gradient at that particular point, you just have to substitute wherever you see x. In this function, you substitute half. Okay, so at x equals to half, f prime of x becomes, so wherever you see x, this becomes 4 into 1 over 2 all raised to the power 3 plus 12 into half. So this becomes 4 into 1 over 8 plus, and this becomes 6. Okay, so this will give you half plus 6, which is 6 and a half. So you just add this, which is 6 half, okay, which becomes your solution. Okay, so we are going to look at example 2. So please, if you don't understand, pause the video or just try to look at it over and over. Okay, all you have to do is just for you to differentiate this one. And if you don't understand how to differentiate, how I have done the differentiation here, please check the YouTube channel. I've done functions, chain rule, check chain rule, okay? So here, all you have to do is differentiate the whole of this using the power, then you differentiate what's inside the bracket. And once you get the answer, you just substitute the value for x, okay? Let's solve example 2. So as you can see on the board, example 2 says, find the gradient of the curve. So we have the curve y equals to, bracket open, x minus 3, and we have x squared plus 2. Okay, so the first thing we have to do here is for us just to find the first differential, and once we have that, we substitute the value for x into the first differential. Okay, so we have to differentiate this with respect to this, differentiate y with respect to x. So here we have two ways we can do this one. We can either apply product rule, or we apply differentiating sum or difference, wherein we clear the brackets, we expand and differentiate the terms. Okay, so whichever method you use, you are going to get the same answer. So let's just go with the sum or difference. So we clear the brackets, This multiplied by this gives you x cubed. Okay, this multiplied by this gives you 2x. This multiplied by this gives you minus 3x squared. And this multiplied by this gives you minus 6. Okay, so now you have the terms. You differentiate each of them. Okay, so you are going to have d by dx of y, which is dy dx, equals to, so you differentiate this one gives you 3x squared, plus you differentiate this, you have 2, minus you differentiate this, you have 6x. Okay, raised to the power 1. And when you differentiate a constant, you always have 0. Okay, so once you have this, the next thing you have to do, you just have to substitute the value. So you're asked to find the gradient at the point where x is equals to 1. So dy dx at x equals to 1. So we substitute, this gives you 3 into 1 all raised to the power plus 2 minus 6 all raised to the power 1. So this is going to be 3 plus 2 minus 6, which will be 5 minus 6, and that gives you minus 1. So the gradient of this curve at x equals to 1 is minus 1, which is your answer. Okay, so let's look at the next one. Example 3. So solution. So example 3 says as well, find the gradient of the given curve at the given point on the curve. And you are given the curve y equals to x squared plus 3 over x. Okay, at the point where x is equals to minus 1. So the same thing, we just have to differentiate this. But before differentiating this, we have to change the division, this. So this becomes x squared plus 3 raised to minus 1. Okay, so taking this one from the bottom, bringing it up, it carries a negative power. Okay, which is minus 1, because the power here is minus 1. So now we differentiate. So we have dy by dx equals to, when we differentiate this, we have 2x. When we differentiate this, we have minus 3x raised to minus 2. Okay, if you want to know how we differentiate, we have done the basics. We are now under applications of differentiation. Okay, under applications of differentiation. So we've done the basics. So for that, we know we always have to subtract 1 from the power, and we multiply this. So now with this one, we can just rearrange it again. So this becomes 2x minus 3 all divided by x squared. Okay, so now at x equals to minus 1, your dy by dx, which is the gradient function, equals to 2 into minus 1 minus 3 all into minus 1 all square. Okay, so this becomes minus 2 minus 3 all into 1. You know, when we square, a negative gives you positive. So this 3 divided by 1 is just the same. So this becomes minus 2 minus 3, which becomes minus 5, which becomes your answer. Okay, so the next we have to look at the last problem, which to me is the most difficult one amongst all the problems. So stay with me until we are done with the last problem. Okay, so let's look at the last question, which is example 4 here. So yes, let's look at the last example. So the last example says it's a bit different from the ones we've done. Okay, the 3 problems are more like asking us for us to find the gradient of the given curve. For the next one is basically more like the reverse. Now we have been given the gradient. Okay, we are asked to find now the values of x for which the gradient is given. Okay, so say find the values of x for which the gradient function of the curve. So we have the curve y equals to, this is x raised to the power 4 divided by 4, which is 1/4, plus 2x cubed divided by 3, okay, minus x squared divided by 2 minus 2x plus 1. Okay, so this is the curve function for which the gradient function of the curve, this is 0. So meaning the gradient function is 0, which is your dy dx is the gradient function. Okay, so it means your dy over dx is equals to 0. But what is your dy over dx? Okay, say but the dy over dx must equals to. So you are now going to differentiate this one. So if you differentiate this, it becomes 1 over 4. That's this just 1 over 4, this one. Now you want to differentiate this. This becomes 4x raised to the power 3. Okay, plus you have 1 over 3, which is this 1 over 3. And of course, you have your 2. Then you differentiate now. The 3 is coming down, x squared, okay, minus. You have the half. Now you have to differentiate this. Okay, multiply, the 2 is coming down, x raised to the power 1, because you are going to subtract 1 here, minus. Okay, so when you differentiate 2x, you have 2. And when you differentiate a constant, you always have 0. Okay, so this, let's cancel. This cancel this. So we are left with dy over dx equals to, this becomes x raised to the power 3. This 3 cancel this 3. So we are left with plus 2x squared. These 2 cancel these 2. So we are left with minus x, okay, which was 2x, that this, and minus 2. Okay, so this is what is left after differentiating and cancelling. Okay, so now what do we have to do here? We are asked to find x. Remember, so this means 0 equals to x cubed plus 2x squared minus x minus 2. How do we factorize this one? Because we have, this is polynomial, okay, the power greater than 2 here. So because of that, what do we have to do? We have to look at this number, the constant here. Okay, we have to determine one of the factors, and then we apply the long division for us to have the other factors. Okay, so from the look of things, we always look at the constant number, that's this number here. Okay, we look at the factors, the numbers that can go into this, the factors of minus 2, okay, or 2. Okay, so we have like 1 plus or minus 1. Okay, we have plus or minus 2. So those are some of the factors that can go into 2. So we have like plus or minus 1, plus or minus 2. Okay, when you multiply, you are going to have something like that. So now, what do we do here? So we are just going to test numbers. We start with plus 1 and test it in here and just substitute it into this function. If it gives you 0, that's one of the factors. Okay, so if we put 1 here, this becomes 1 cube, okay, which is just 1, and we'll put 1 here, that gives you 1 times 2, 1 plus 2 other, because 1 square is just 1. So this becomes 3 minus 1 and minus 2. Okay, so it means if this is 1 cube plus 2 into 1 square minus 1 minus 2. Okay, so this gives you 1 plus 2 minus, that gives you 3. So 3 minus 3, which is 0. So you always have to look for a number that when you plug that number into this, gives you 0. And that's how we determine the first factor. So it means since the number that we substitute in here is positive 1, it means that x minus 1 is a factor here. It means it's a factor of this function. Okay, because when we have x minus 1 equals to 0, we are going to have x equals to 1. Okay, so because it's positive, you are going to put negative here, x minus 1. Because at the end of the day, if x minus 1 equals to 0, you are going to have x equals to 1 as well, which is the same thing here. So now that we know x minus 1 is a factor, of this, we are now going to use the long division by putting x minus 1 outside the bracket and put this one inside the bracket, which is x cubed plus 2x squared minus x minus 2. Okay, so this, we are now going to determine how many times this can go into this. Okay, so x into this becomes x cubed, x squared here. So x into this becomes x squared. Now this number you have, you are going to multiply it throughout. So this time this gives you x cubed again. Okay, this time this gives you minus x squared. Now the other ones, you are just going to add plus 0 plus 0. Then you give a bracket and put minus outside. Okay, so you subtract now. X cubed minus x cubed gives you 0. Okay, minus times minus gives you plus. So 2 plus 1 gives you here 3x squared. Okay, and these ones you just bring the other ones, minus x minus 2. Okay, so the next one again, you determine again x into 3x squared. That gives you plus 3x. Okay, because 3x again multiplied by this will give you this. So you have again here 3x squared. Okay, now the next thing, 3x now multiplied by this gives you minus 3x. The same thing again, the other one now you add 0. Okay, and you give a bracket minus here. Then you determine again this minus this gives you 0. Minus times minus gives you plus. Minus x plus 3x gives you 2x. Okay, because you are subtracting. This is positive 3 and this is minus. So you have 2x and you bring this guy here minus 2. Okay, so now next again, we have to determine again x into this gives you plus 2. Okay, so this into this gives you 2x, and this time this gives you minus 2. Open the bracket again and divide. I mean, you multiply. So this and this you subtract is 0. Plus times minus is minus times minus is plus, and plus 2 minus 2 gives you again 0. So until you have here 0, 0, then you know you've gotten your answers, the other factor. Okay, so now for this we have these factors. Okay, so x cubed plus 2x square minus x minus 2 is equals to x minus 1 and the other factor x square plus 3x plus 2. Okay, but being that, remember we are looking for the values for x. So let's simplify this again. This is now quadratic. So we are going to look for two numbers that when we multiply them, we have 2. If we add or subtract them, we are going to have 3. And those numbers are going to be 2 and 1. Positive 2 and positive 1. So we have to factor this guy. So now we have x minus 1, which is one of the factors. And factor this, we are going to have x squared plus 2x plus x plus 2. Okay? So this everything here must equals to 0. Okay, so we have x minus 1 into, now this you can open a giant bracket. So this one 2, this again, so you separate them, 2 2's. Okay, so what is common here? X is common into what is left, x plus 2, close bracket, plus what is common here, 1 into x plus 2, close bracket, giant bracket equals to 0. Okay, so let's come here. Okay, so let's finish it off. So here we have x minus 1 into, what is common here is x plus 2. So we are going to have x plus 2 Then what is left? X plus 1. So we are going to have again x plus 1. Everything here equals to 0. So we equate each of these brackets to 0. So this becomes x minus 1 equals to 0, x equals to 1, because you transpose this one. Or you have x plus 2 equals to 0, x equals to minus 2. Or you have x plus 1 equals to 0, so x equals to minus 1. So therefore, the values for x is to x will be what? You have minus 1, comma, you have 1, or minus 2. Okay? So this becomes your answer. Minus 1, 1, and minus 2. Okay? So that's it. So if you've been with me so far, thanks so much, and I would appreciate if you click subscribe to this channel so that you don't miss out when I upload any content. Okay? So please share, give the video a thumbs up, and click the notification bell so that whenever I upload a video, you'll be the first to be notified. Okay? So thank you so much, and be ready. Just check the YouTube channel to see the other topics we have done.